Okay, everyone, let's do one last video about databases and information searching, retrieval, information foraging, that sort of thing. So let's hit non-relational databases. And I will fully admit, I have not actually been studying these at all. I have not actually made a NoSQL database. I have friends that do it, other researchers that do it, but it's not my area. What I do know is some of the foundational ideas behind it, but at the same time, it's if you want to use a NoSQL database for your assignment, great, fantastic. And many of you have actually been doing this, so I will defer to your expertise in certain cases. However, let's just do, for people that are not used to a NoSQL database, let's go to what the heck we're looking at. So when we're looking at a relational database, we had a series of tables that are hooked together that you can see the relationship between tables. You can join tables to get the information that you're looking for. You can filter, you can join, you can do inner and outer joins, you can do all sorts of things to write queries that will get the information you're looking for. And you're also trying to minimize the amount of data that you're storing. A NoSQL database, on the other hand, uses, at the very, very, very basic level, key value pairs. Pairs, or tuples, if you will, of a particular numeric key, or key to uniquely identify each of these elements, and the value that's associated with it. So in a given record, let's say if I have a whole bunch of different pieces of information, like my address and my phone number and a picture of me and a bunch of other information, each one of those pieces of information would have an ID, and it would also have associated with it the information, the value that you're looking for. And if you string a whole bunch of these together, you would get a record. Now, what's interesting about this is that it does mean you presumably will have more repeated data than you would with a relational database. But it also means that you get some major advantages from this. And so examples of it might be MongoDB, which is an open source NoSQL database. Cassandra is actually being used by Facebook. Bigtable used by Google. There is a number of these technologies out there currently, and they work very similar way. You can even use, I think you have a SQL-like language to access it or to write a query. But as a result, and so what you can do is layer on top of just these simple key value pairs, you can layer on top of that to necessarily access records or images or things like that, a larger scale or more elaborate data structures. It can scale really well though, because you can duplicate the code or duplicate the data in other locations, so you don't have fault necessarily. If they're uniquely identifying each individual element, even if you duplicate the elements, you know you can find it or where to find it. It's hardware fault tolerant as a result. It's distributed. It's fast as hell. It doesn't guarantee ACID standards. So the standards that you get for the SQL database are not necessarily there, or it's up to the developer to build it to guarantee that. So for Cassandra, for example, if you do, I think you, when you alter, I think you add or remove records from the database, what ends up happening, if you do it in rapid succession and then try and access it, you will get random or inconsistent information back in those situations. Right? Things like that you would not get in a SQL database. You can get in a NoSQL database. The SQL database would be like stable from it is querying one database, not somewhere in the world there's a database. But that also means that you can't distribute your data everywhere. So guaranteeing the stability or the stability and sort of ACID standards for NoSQL database is not only damn hard, it's like relying on the programmer to release your memory when you're writing C++. People will screw it up, and so you can expect some screw ups along the way, and it puts the onus on the programmer. Read-write operations are nearly the same time often cause these kinds of problems, and really it depends on what you need for this. So what we're talking about is interaction, right? A NoSQL database is fantastic if you want, like, I'm trying to store all tweets that people make and about information about that person. Great use of a NoSQL database. That's where it's used. If I'm looking at Facebook posts, oh, something went wrong and I lost a little bit of data. It's not, it's a big deal for Facebook, sort of, but it's not really the end of the world. If there's a little bit of corruption in your data every once in a while, it's you can get corruption in your data from having the hardware break on you. These kinds of scales. If I'm talking about a SQL database, for if I'm doing financial transactions or if I'm dealing with a bank, I do not want to be using a NoSQL database. They should work in concert. One, they're different tools. They do different things. Like C++ versus Python. Not one language is better than the other. It's just they're used for different things. So if you want to see a horrendously, I'm hopefully not going to play it by accident. If you want to see a horrendously offensive, it's not that offensive, but still, it was a very eye-opening video when I watched. I'm like, oh yeah, that's a good way of looking at things, or an interesting way to look at things. When to use a relational database versus NoSQL. So you can watch it at your own risk. There's a lot of bad words in there. Okay. Once we've got past that, if you are like me and I've been doing a fair bit of database stuff now, but I'm not a database expert. So if you do not have a database experience, that's fine. There are ways of getting data into your system without necessarily, and we're not even going to look at like pandas tables, pandas pages. Oh, darn, forgetting the word. We're not going to look at pandas right now either, but that's with Python, by the way. What we're going to look at, the other approach you can take is just a flat file. Now, XML, you can actually make it not necessarily flat. You can have hierarchical information, but JSON and XML files, well, JSON's a kind of XML file. They're marked up text files, essentially. And it's a way of encoding data as text, and it's incredibly flexible. So if you have the ability to store, retrieve, write to an XML file, that is a perfectly fine, acceptable alternative for your projects, especially if you don't have really large data sets. Even comma-separated value files or tab delimited files would be acceptable if you have a proper format. You can use almost anything you want. These are one of the benefits of using these approaches. They are not robust. They are not error-proof. They're not a lot of other things. But if you have a relatively small data set, you can handle it with these kinds of things. It's fairly straightforward in terms of a technology. It's just a text file. You don't have to spin up a database or anything like that. You just have a text file that you can pass around. Heck, you can pass it to the client. So, by the way, in case you're wondering, JSON is a way of encoding object information. So let's say I have an object in a language like C++. I can encode the information about that object from that class in a text format, send it across the wire. So I say that I have this field and it has these properties associated with the field. I encode that as text. I can send that to another computer. So from the server, let's say, send it to the client, what the user is using, and the other computer can take that file, read it, figure out what object it needs to make, and regenerate the object on the other side, like a transporter in Star Trek, right? You beam from one location, you send the atoms one way, and then you reform on the other side. XML and JSON files are really good for that because there's a sort of a standardized approach to how you encode information, and it's very well established that you have these out of the box ways of processing JSON files. Comma-separated value files are also perfectly fine. It's in every single field. I have a record on a line, and every single field or every column in the record, or every column in the table is separated by a comma, and that way you know where the next field is. It even turns out that JSON is actually being used by Altair. So when I make an Altair visualization and save it or export it to being Vega Lite, it actually writes a JSON file to send to pass this off to the renderer. These kinds of files can actually be generated fairly easily, and that's one of the real big benefits of these flat files. So if you don't know what you're doing, I suggest, as a first approach, don't worry about a database. Just throw in either XML, JSON, or CSV file, so to store and retrieve your data. That's not the point of the course. Is not to have some badass database. It is to make the interaction with the data as painless as possible, or to look into what's the best approach. If your data set is small enough, something like a flat file is perfectly acceptable. If you have a massive data set, or massive data, if you have a massive data set, you got to go with the database. It'll be too slow loading in an XML file. So it depends on what your use case is. But Python has lots and lots of ways of reading JSON files, XML files, CSV files, I think tabular limited files, and even you can spin up databases with Python. So in all these cases, a quick Google search would be information seeking, but hopefully information retrieval, but it might be information seeking. You can do any of those approaches. So just look it up before whatever you decide to use. This is just as a outline to say what your options are. And so what? Well, that's the point. We're not really spending all of our time talking about databases because that's not what we're supposed to be looking into. Just make a decision and know why you're making that decision. Don't just randomly choose it. Why am I using XML? I don't have experience in database. Why am I using a NoSQL database? Because it is a massive set of data, or I'm using Google Cloud Platform or AWS. Right? If you know a big table, you know AWS, go for it. You can use that. That's fine. The database performance, from my perspective, or the stability, or the not cleanliness, not the word I'm looking for, the robustness of a database only really matters to me if it's going to potentially crash during your demo, or if it slows down the user so much that they actually see it and notice it. Provided you don't have that situation, do whatever you want. So I do strongly suggest local data. I'm suggesting keeping local data and loading local data on your machine if you can, if it's going to make your job easier. One of the benefits of using local data is that you can save it to your machine, and 2 years down the road, when you're showing off or whenever you graduate or you're applying for your next job, you can show off your project without having to worry about did the data change over that period of time, right? There's a nicety about being able to run it locally, because then you don't have to worry about is the data going to go away. All right, I'm going to stop there, and what we're going to pick up next time, I do believe, is I'm going to deep dive into perception and cognition. This is actually where I know more about than databases for sure. Those lectures are going to be potentially a bit long. Try and bear with me. I'm going to try and chop a bit more. I scheduled one lecture for it, and I'm like, I got 4 lectures worth of material here. So I'm going to try and chop more, but that's what's coming up next. It's going to be perception, cognition, and why visualizations like what we looked at in that paper, the Jeff Heer paper, why do they look that way? Why do they design things a particular way? All right. Thanks, everyone. I'll talk to you later.